It's 1980, and a cartographer pores over detailed maps of the shoreline, color-coding every environmental resource. It's 1951. As commercial fishing boats come in off the Pacific Ocean, a dockmaster documents each boat's cargo. It's 1919, and a field biologist stops to jot down notes on his birdwatcher observation cards. Over the decades, scientists have carried out their work. Entire bodies of their research now sit in warehouses, basements, and remote library shelves. It is here in these resting places and storerooms that the vast scope of our finest research sits, rapidly deteriorating in antiquated formats of paper, microfiche, and brittle film. However, all that is changing. This irreplaceable body of historical climate and environmental data is finding a new and urgent purpose in a race to understand the world's most pressing challenges. The organization responsible for making historical climate and environmental data accessible again is NOAA's Climate Database Modernization Program, an effort of the National Climatic Data Center. Historical climate information is one of the more valuable commodities in science today. When environmental emergencies arise, responders rely on data rescued by CDMP to help make timely decisions. NOAA scientist Jill Peterson explains how environmental sensitivity index maps provide critical scientific data in the case of oil spills.
The ESI maps are always the first step in initially assessing what resources you will want to protect in the event of a spill. With them, the Coast Guard can take the ESI maps and say, this is our highest priority to protect. They can figure out how much protection equipment they would want to bring in. With the Deepwater Horizon spill, the ESI maps were used from day one to come up with a baseline of what resources were potentially going to be impacted by the oil release from the well. Could we protect all of the swamp or marsh areas that are so fragile when they become oiled and so difficult to clean out? CDMP has been useful for us in this ESI project in order to have the data safely available to a much broader audience. It's just a world of difference than the status of the ESI maps before.
In another project, data from 90 years of fish landings are helping manage commercial catch limits in the fishing industry.
All we had were these boxes of microfiche, which we knew had the information we wanted to use, but we can't use it in our normal stock assessment work because there's no way to get it from the microfiche to the computer. CDMP is now recapturing the microfiche data in an electronic format that we can use. Before the CDMP data, we were forced to use just educated guesses of what the early catches were. We've been able to replace those educated guesses with pretty solid numbers, and as a result, there's going to be a wealth of uses, everything from coastal management to economic assessment, the whole thing. So CDMP has been critical to making this work.
Some of CDMP's most obscure data collections are proving surprisingly valuable. One rescue effort is the Bird Phenology Card Scanning Project. For over 90 years, a vast network of birdwatchers recorded their observations on simple note cards. Nearly 6 million cards are now part of the permanent research records. These birdwatching cards have become extremely valuable to climate science. Multiple organizations, including the FDA, the U.S. Fish and Wildlife Service, and the Cornell Lab of Ornithology, are using bird data to track the biological response to climate patterns and change.
Because there's so much interest in bird activity and because bird migration has been recorded for such a long period of time, we have a lot of data to work with. Birds are also very sensitive creatures, and the variations in climate change are most likely to affect them. So if we can see it there and how they're affecting birds, we can make a case for how they might be affecting other species and other animals within the ecosystem. The funding from CDMP has made a huge impact on our program and has greatly sped up the progress that we're able to make. Now we are sorting and scanning and making these cards available at a much faster rate, and we wouldn't have been able to do that without CDMP's help.
In 11 years, CDMP has restored an astounding 54 million images and over 14 terabytes of data, scanning millions of documents with the help of private sector contractors. In 2010, CDMP is managing nearly 100 data rescue projects and creating over 300 high-tech and data entry jobs in 4 states. In the next decade, CDMP will be working harder than ever in a race to save 130 million more deteriorating documents. Scientists in nearly every discipline are waiting, hungry for information, and as more data becomes available, demand grows. Climate data rescued by CDMP impact agriculture, engineering, healthcare, and manufacturing. They help establish accurate trends in climate change, define patterns in the spread of disease, and create models used to predict drought and flooding. In short, information from CDMP projects impacts our economy, our nation, and the world. Thanks to CDMP, some of the most exciting news in science today is coming not from new discoveries, but in rediscovering what we already have. Our country's historical climate records are becoming a valuable resource, a highly sought commodity, and perhaps the greatest of our national treasures.